In the last lecture, we were introduced to the beautiful Platonic solids. These 5 regular solids that all display the kind of symmetry that appeals so much to the human spirit. Each of these solids, remember, the defining property is that each face of each solid is the same as every other face, and each vertex has the same number of edges emitting from it. For example, in this tetrahedron, there are 3 edges that come out from every vertex. Now, the question that still puzzles us in this sequence of lectures is, why are there only 5 solids? We've said there are only 5, but we haven't yet actually proved that there are only 5 regular solids. In the course of investigating that question, of actually seeing that indeed that is the case, that there are only 5, and there can be only 5, there will always be only 5. In proving that, we're going to see several methods of thinking that are intriguing and are apt and appropriate for dealing with worlds well beyond mathematics. One method is to try things and fail. Making a mistake and then learning from the mistake and seeing why that attempt fails is an excellent way to force us to see what is true. That's a terrific strategy for thinking. Well, so let's begin now with trying to analyze why we couldn't have a 6th regular solid. The first proof will be more direct and the one that you'd more naturally think of. Namely, we're going to start with the building blocks for the regular solids, triangles, squares, pentagons, and so on, and just try to put them together. And then after we try, we'll see that we can't put too many of them together. We can't create more than we have. So let's start with triangles. If you take 6 equilateral triangles, you might ask the question, could there be a regular solid in which 6 edges come from each vertex? You see, in the tetrahedron, there are exactly 3 triangles that come from each vertex. In the octahedron, there are exactly 4 triangles that come from each vertex. And in the icosahedron, there are exactly 5 triangles that come from each vertex. So you might ask the question, would it be possible to have 6 triangles that come out of each vertex? Well, so let's just take 6 triangles and assemble them and just see what happens. If we assemble them, so here I am assembling these 6 triangles. There you go. 4, 5, 6. You see what happens is it's now flat. Because each angle is 60 degrees in an equilateral triangle, and if you put 6 of them around, you get 360 degrees. It's flat. So it never folds up. It can't possibly fold up to create a solid. So that's a proof why you can't have more than 5 triangles coming out from one vertex and making a new solid. So that there's no hope in making a new solid that has 6 triangles. Let's try squares. Suppose you had, you know that the cube is the only regular solid that has square faces. There are 3 squares that come out of each corner of a cube. You see that every day. You look in the room, the corner of the room, there are 3 squares that come out of it. So if you tried to make a regular solid where at each vertex there were 4 squares coming out, well, you put them together and you see once again that you would have something that's flat. So it would never fold up on itself. So you can't have more than 3 coming out from each vertex. And finally, if you have pentagons, if you look at the pentagons, well, any pentagon has angles such that if you had more than 3 of them, of course it would be too much. It would be more than 360 degrees. So you couldn't have 4 pentagons all coming around one vertex. They wouldn't close up at all. In fact, you couldn't even make it flat. And finally, you might say, well, is it possible to have a regular solid where each face has 6 sides? Is it hexagon, or 7 sides, or 8 sides? Well, let's see what happens with 6 sides. If we have hexagons, and we made 3 of them put together, you know that every vertex has to have at least 3 things coming out from it. If there were only 2, it would be squashed flat. So if there were 3, then it would be flat again. And so it wouldn't fold up. Therefore, you can't have a regular solid that has hexagonal faces. So this is the first kind of argument that can be used to show that indeed there can be only 5 regular solids. By the way, I should say, I didn't actually mention this, that if you start out with, say, 3 squares coming out from a vertex, then everything else is forced. If you decided, okay, I'm going to make a solid, and I'm going to have 3 squares coming out. Well, you put the 3 squares, then it's rigid. They have to be in a specific place. And then you can go to a vertex there and say, well, I need 1 more square. You put it in. You need 1 more square. And you construct the cube. There are no choices in the way that you construct it. And in fact, every one of the possible collections of triangles coming out from a vertex, 3 squares coming out from a vertex, and 3 pentagons coming out from a vertex, each one of those does in fact create the regular solid that we see here. So that's one kind of argument that leads to the fact that there are only 5 regular solids.